term I want to define is atomic radii. You know what a radii is? The plural of radius. You knew that. Okay, so half the distance across a circle. And we define it as half the measured distance between the nuclei of two atoms, that are identical atoms that are bonded together. Why would it be important that they're identical? So let me draw this for you. Let me draw this. So we have one atom, we have two atoms. There is a distance between those radii. That's the nucleus. Here are our little electrons out here. Our electron cloud, our big fuzzy narrow area where the electrons are somewhere in there. Why would it be important that those two atoms be identical atoms? They can be very different sizes. We could be talking about something like hydrogen and iodine. And at that point, half that distance is not the radius of either one of them. It's some weird average that doesn't really relate to either of them. So we only describe this as half the distance between the nuclei of two identical atoms that are bonded together. All right, so now we have some trends to talk about. If you would be so kind as to get out your old friend, the periodic table, most of you have it out, your color-coded one even. We really can't even see this. There we go. Okay. So, if you look at that periodic table, and we look at group 1. So let's pick as an example atomic number 19, okay? Potassium, okay? Thanks. Okay. And if we go all the way across that period to krypton, Kr, what I'm going to tell you is that the atomic radius is littler. Really? The atomic radius of krypton is smaller than the atomic radius of potassium. So now, let's think about why that might be the case. So, from krypton over here, or from potassium to krypton, what have we done? What have we done? What's changed? What's different? Added more protons, neutrons.
Stuff. Yeah,
We've added more stuff. Okay, in general, so we've added more protons. This is true. We've added more neutrons. This is true. Neutrons don't really affect a whole lot of things. They just contribute mass. And we've also added more what? Electrons. Okay. More protons, more electrons. So why would that make the atomic radius smaller?
Because the nucleus gets big, really big, so a lot of stuff on it. So there's less distance between it.
Okay, so we have one hypothesis, that the nucleus gets really big because there's so much stuff jammed into it that there's less distance between those two nuclei. You feel like that's a viable hypothesis? Okay. Any other hypotheses? No idea. Okay. Because poof, it was made so. All right. Neither. Okay, now let's leave that question alone for a second, and let's give you the other little brain teaser. Let's go back to group 1, and we'll go all the way up to lithium, Li. Atomic number what? 3. Yes. If we go from lithium down the group to francium, down here at the bottom, big, crazy, heavy, radioactive francium, the atomic radius increases.
There goes my theory.
Grrr.
That just...
Yeah, that kind of just shot your hypothesis right in the
We
butt,
have a
didn't
paradox here.
it? We have a paradox. Okay, so let's do some drawing and see if we can figure this out.